Hello everyone, today we're going to start our Unit 5, and we're going to start with the notes. Trying to get rid of things while I'm talking, it's never fun. So, today our Unit 5 is about systems of equations. So let's go ahead and start with the vocab, so we know what those are. So systems of linear equations is basically two or more equations. We group a couple of equations together and deal with those equations. A solution to a system is an ordered pair, so an x and a y, that represents the intersection of the equation. That's what it looks like graphically. It's where the lines all meet. Now, algebraically, it's the ordered pair, or the x and y, that will make every single equation a true statement. Okay, so if you plugged it in, they'd all come out true. There are three different types of systems, like three different kinds you can get. And they have like fancy names. We're not going to go into the fancy names. Basically, when you graph two equations, there's only three ways the lines can interact with each other. One way is where I drew lines. I drew lines. I know I did. They intersect like this. So they actually cross each other. And when that happens, the intersection of those two lines is your solution. So when they cross, that means you're going to have one solution. Okay? Another kind of equation is when you graph them and they're actually parallel. Okay? Two lines that never cross. And what that means is that you don't have an intersection point, so that means you don't have a solution. There is not one ordered pair that will work for both lines. Okay? So parallel lines mean no solution. Okay? And the last one is actually when you graph the two lines and they end up being graphing the same line. So they're right on top of each other. Okay? And it just means that there's two lines. When this happens, I strongly advise you to do two sets of arrows. That will show me that you have two lines there rather than drawing them on top of each other. But when this happens, every ordered pair on both lines works for both of them. So this is an example of infinite solutions when they overlap. Okay? Now, in addition to the different types of systems, there's actually three different methods to find a solution to a system. Okay? And every day we're going to do a different method. So today we're focusing on graphing. Okay? And there are 4 steps to solving systems by graphing. Step 1, change each equation into slope-intercept form. So y equals mx plus b. Okay? That way you can have an equation that you can graph. Step 2 is to graph the first line. Step 3 is to graph the second line. And then step 4 is just to find the intersection and that intersection is your solution. Okay? Alright. Is that it? Oh yeah. I'm sorry if this is written at the bottom of your page. We're going to move on to the next page. It's that example. Okay? So we're going to find the solution to the following, not solution, that's supposed to say system. Anyway, so I have two equations. What I like to do is color code them because I'm going to have to draw both of them. That way I can make sure I know which one I'm doing and not accidentally graph the same one twice. So this top one, I don't remember what color I'm going to make it, but anyway. The bottom one, since it's already in slope-intercept form, I'm going to actually change it. But I'm going to make that my green line. Now this one, when I worked it out, it ended up being wrong. And I fixed it and everything. But we need to cross out this plus sign. So please cross out your plus sign and make that a -4. Okay, so this bottom one should be y equals 2x minus 4. Y equals 2x minus 4. Oof, I feel bad for those people who aren't listening to this. So you're going to fix that. Now this top one is not in slope-intercept form, so I need to change it. I need to get y by itself. So I'm first going to rewrite it. So 3x minus y. First thing I need to do is subtract 3x from both sides. The x's will cancel out, so I'm left with -y equals 3x plus 6. Then I'm going to divide every single term by -1. And now I have y equals 3x minus 6. Okay, and that I'm going to do in blue. Okay, so now I just need to go ahead and graph it, and there's no special trick. It's the exact same thing that we did last unit, and we're just going to put them on the same graph. So I'm going to graph the blue one first. So first thing I'm going to do is graph the y-intercept at -6. So 1, 2, 3, 4, 5, 6. I hope this works. Yay. And then I'm going to use 3, which is really 3 over 1, as my slope. So I'm going to go up 3, 1, 2, 3, and over 1, graph my second point. Then I have 2 points. I mean, I could keep going and put more dots on it, but I'm just going to go ahead and draw my line. So that's my blue line. Now I'm going to do my green one, and I'm going to start with my y-intercept of -4. So 1, 2, 3, 4. Let's see if it'll graph. There we go. And my slope is 2, so I'm going to go up 2 and over 1. Oh, there we go. I know it's really close together, but it's okay. And now I'm going to go ahead and graph that line. Maybe, maybe not. Who knows? Who can tell? There we go. And now that my two lines are here, I'm going to look for where they cross. And they cross right here. So my solution is that ordered pair. So when I write my answer, I write solution, and then I write the ordered pair where they're crossing. 2, 0. Okay? You guys are going to try this one on your own. Okay. Example 2. Find the solution to the following system. So first thing we want to do is make sure they're in slope-intercept form. First one already is, so I'm going to make that one my blue line. The second one I need to adjust. So again, I'm going to rewrite it. So 4x minus 2y equals 14, and just get y by itself. So I'm going to subtract 4x from both sides. And now I have -2y equals 4x plus 14. Divide everything by -2. And I get y equals 2x minus 7. Now you might notice right now, these two lines, or these two equations are the same. And you might remember from that first page that, well, hey, if they're going to be the same equation, they're going to graph the same line, and that means a certain kind of solution. If you can recognize that without having to graph anything, great. However, sometimes you're just going to have to graph it. Okay? So we're going to graph these two equations. And yes, they're the same, so we're going to try and deal with it. So first one is at -7, which is right here. I'm going to do it in green first. And the next, and then I go up 2 and over 1 and graph my line. Oh, well, I tried. Graph my line, and then I do the same thing for my blue, and they're actually the same points. And I draw my line. So, I know this is kind of hard to tell, okay? But they are actually on the same exact line, okay? I spread them out a little bit so I can see the two different colors. I don't know why I'm doing hand signals like you guys can see, but they are the exact same line, okay? So when they are the same line like this and they overlap, that means I have infinite solutions, okay? And now you guys are going to try. Oh, no, you're not. I'm going to do example 3 first, and then you'll do 2 try on your own. So now I need to find a solution to this system. Okay, so neither of them are in slope-intercept form. So I have to do that first. So I'm going to start with the top one. I'm going to make that blue. I'm going to divide everything by 2 because that's all I need to do. And I get y equals -5x plus 1. Now for the other one, I'm going to get y by itself, if I can figure out where I put it, by subtracting the 5x from both sides. So I get y equals -5x. And I don't have a y-intercept here, so I'm just going to plug in a +0. Okay, so now I'm going to go ahead and graph it. So I start off with the y-intercept for blue, and that's at 1. And I'm going to go down 5 and over 1. And once I have my points, I'm going to plot my line. And then for y equals -5x, I'm going to go ahead and start at 0. Oh, Where's my point? Anyway, there it is. And go down 5 and over 1, and I plot my points. Now, again, it could be a little hard to see because I made my points and everything really big, but these are actually parallel lines. They're not quite on each other because their points aren't exactly the same, right? So these are two parallel lines. You could notice that just from the slopes. They have the same slopes, so they're parallel lines. Okay? And when you have parallel lines, that means they're not going to cross at all. So that means you have no solutions. All right? Now you guys are going to try A and B on your own. Okay? The next one, we have to write the system and find the solution. Now, if they give you the system already on the graph, finding the solution is really easy. You're just finding where it crosses. Writing the system, still not that bad because all you're doing is writing the equation for the line. Okay? So I start off by color coding them because I can. You guys can highlight them, different things. You really only need one color. But I started off by doing that, and I did my little squiggly brace. You only need one. So for the green line, I noticed that my y-intercept is right here at 1, 2, 3, 4, 5. And then I looked for my slope. So I go down 1 and over 1, 2, 3. So my slope is -1 over 3. Okay, and I just wrote my equation. Here, my slope is at not my slope, my y-intercept is at -4, and I end up going up 2 and over 3, so my slope is 2/3. So once I have those two equations, I'm done with the system. That's all I needed. Now I can look for my solution, which is where it's crossing, right here. Where's my little circle? And I just need to write that ordered pair. So the solution is at 9, 2. That's it. Right? You guys have one to try on your own as well. Now the last example, is this the last one? Dang, I went through this fast. The last example is, oh goodness, is with 3 equations. This is an honors topic where you would have 3 equations going on. Okay? And with 3 equations, all you're doing is looking for the intersection of all 3 lines. Okay? So I need to find where all 3 are crossing. So I'm going to graph each one. First, I'm going to change them. Okay, so this guy, I'm going to make my blue. This one, I'll make my green. And this one, I will make my yellow, my purple. So I start over here, writing it out. I did it very small, I'm sorry. And I'm just going to get y by itself. So first, I'm going to subtract 4x from both sides. So now I have -y equals -4x minus 6. Divide everything by -1. So now I have y equals 4x plus 6. That's what I'm going to graph. So I go up to plus 6, which I think is right here. And I'm going to go up 4 and over 1. And then I just graph my line. Okay, that's my first one. For my green line, I'm going to change it to slope-intercept form. So I'm going to subtract x from both sides. Then I have -2y equals -x plus, minus 5. Divide everything by -2. So I get y equals 1/2 x. And then this -5 over -2, I'm just going to leave as plus 5 halves, which is really 2.5. So this might be a little difficult to graph, but it's still doable. So I go to 2.5, which is right here. Oop, not there, not there, not there. Ignore the red. Right there. And I'm going to go up 1 and over 2. So it's going to be right here in the middle. And then I graph my line. Okay? Now I have to graph this last one. And if you remember, if it's just one variable, that should trigger Hoybucks. Okay? If it's x equals, that means it's going to be a vertical line at -1. So here's -1. And I'm just going to draw my vertical line through it. Okay? Now, all 3 lines are intersecting at this one point. So that is the one solution for this system. So my solution is -1, 2. Okay? That's all it is for today's video. If you guys have questions, please write them down, and we can talk about them next class. Otherwise, that's all I got for you. Okay? Bye.